In computer science, data structure refers to a storage format that is used to store, retrieve, and organize data. However, in the world of computer science, there's a lot of data structures, and each one differ from the other in terms of how they store data, which structure they use, and the time complexity, which is very important. In this video, we will discuss a common data structure known as stack. Stack is a simple data structure that uses the concept of last in, first out. So the last element that enters the stack is the first element to get out. This is our stack. Let us add the number 1. It is stored at the end. Let us add the number 2. It is stored on top of number 1. And let us store number 3. Now, to take off the elements, we start from top to bottom. So number 3 goes out, and then number 2, and then number 1. So this is stack. Last in, first out. Today we'll be implementing stack using Python programming language, and we'll be using classes and objects. So if you need to refresh your memory on classes and objects in Python, make sure to visit my playlist, link in the description. Let us start by creating a class called stack. This class will have a init method, which this init method takes only self as parameter. However, we'll use this init method to initialize a instance variable. We'll call it self.lst equal to an empty list, and this list will act as our stack. Now, why did we define the list inside the init? Because we know that when we create an object, like let's say stack1 equal to stack, we know that the init method is called automatically. So at each object you create, there will be a list created automatically for it. Now let's start with our first method, which it will be isEmpty. This method will return either true if the stack is empty or false if the stack is not empty. So it's very simple to do it. So def isEmpty, and it will of course return a boolean, so self, and I will say return. And because we are using a list to simulate our stack, we know that if we say len self.lst, it will return for us the length of the list. And now if we compare this expression with 0, it will either return true or false. So if the length of the list is equal to 0, it will return true, else it will return false. So if you want to try this method, all we need to do is say stack1.isEmpty, and let me print this so we can see or visualize the output in the console. As you can see, we got true because our stack is actually empty. The next method is the size. This size method will simply return for us the current size of our stack. So def size, and it will take self as parameter. So I'll say return, and how can you find the size of the list? Well, you can use the len function. So len self.lst, and this will return for us the current size of the list. And if you want, let's try this function, method. So stack1.size, let me run my Python file, and there is 0 because we have no elements inside our stack. Nothing fancy here, all these methods are very simple. Now we need to start with the method push, which adds data to our stack. So what we'll say is def push and self, and it will take another argument, parameter, which is data. So this is the data that we want to store inside our stack. Now a question for you, how do you store data inside a list? Well, you can use the append function. So here I can do the same thing because the list represents or simulates the stack. So what I can do here is say self.lst.append data. So basically I'm calling the list that belongs to the object, the self object. So in my case, if I say, let's say stack1, let me take off this print statement. Okay, so now we're adding an element. Let me just add 2, let's say. So self here represents stack1, so stack1.list, the list of stack1, and we're appending or adding inside this list the data, which in my case is 2. And let me say print, let's say stack1.size, and let me run my Python code. As you can see, size is 1 because we actually have one element inside our stack. So this is the push method. It's very simple. All I need to do is append the data inside the list, which represents our stack. Now let's go and create another method which allows us to fetch data out of the stack. It's very simple also, but we need to take in consideration a very important condition. First, let's write def, and this method is called pop, so self, and it doesn't take any other parameter. First of all, if the stack is empty, that means there is no data inside, so you cannot fetch any data. That is why we need to be able to handle this. So I will say if and self.isEmpty, And remember, isEmpty returns for us either true or false. True if the stack is not empty, if the stack is empty, and false if the stack is not empty. So I will say if self.isEmpty equal to true, that means the stack is empty, there's no element inside. I will say raise exception. It's basically a simple message I want to print or showcase in the console, and I will say stack is empty. Very simple. Well, here, if at least the stack has only one element, I want to be able to fetch it. So I'll say here return. And how do you fetch an element from a list? Well, there's a special function called pop, and we can use this function to fetch element from the list. So if I say self.lst.pop, I will fetch the element that is at the end at the last index. So an example here, this is a small list. When you say, well, let us call it list. When you say list.pop, it will return 3. So it will pop the element at the last index. Now how this works with stack? Well, remember with the animation I showed you, the first element was 1, then it was 2, then it was 3. So 1 was at the bottom, okay? And you cannot take off any element from the bottom, you need to start from above. And what was the above element? It was 3. So as you can see, when I say self.lst.pop, it will pop 3 as the first element. Okay, so let's try this method. I said here stack1.push2, and now let's say stack1.pop. And actually I need to print this. So let me go ahead and say print, and let us see which element was popped. Of course it will be 2 because we only have 2, and there it is. So we pop the element 2, and remember, when you pop an element, it will completely take it off from the list. So if I go ahead and say print stack1.isEmpty, now if I run my code, and as you can see, it's true, the stack is empty because we completely took off the element from the stack. Now let's create a simple display method that will print for us the elements of the stack. So I'll say def display, and it will take self as parameter. Let me write it correctly, so self, okay. Now we know that the list is representing our stack, so we can actually loop inside this list and print the elements out of it. We can do that. So what can I say here is for I in self.lst. So basically I am looping inside the list belonging to the self object, or whatever this object is. In my case it will be stack1. Now I'll say print, and I wrote print wrong, so print using an S string. I'll put this just to make it better in the console. Now inside curly brackets, I'll add I, which represents the element. I'll press another tab, a bit of backspace, and okay. Now let's go ahead and add some elements. Let me first of all stack.push1, and then stack.push2 and stack.push3. Like this, we added 1, 2, and 3, same as the animation I showed you earlier. So now I'll say stack.display, and let us see what we will get in our console. So run Python file. Okay, I forgot to actually add another vertical line at the end, so let me just do that. I will press right here. Okay, this is it. As you can see, it is printed in a more fashionable way, but there is a problem here. As you can see, 1 is on the top, but if you remember from the animation earlier, 1 was on the bottom and 3 was on the top. So what is exactly happening here? As you can see, we added 1 first, so 1 should be at the bottom. But here, when we are looping inside the list is like this. So I'll write it for you in a comment. So I will start with 1, then we'll start with 2, then ends with 3. So it will print 1 at the beginning, then it will become 2, then it will become 3, and it ends here. However, this is wrong. What we need to do is to tell Python, or tell the for loop, to start with 3, then 2, then 1. So I need to start in a reversed way. And how to do that? Well, it's actually very simple. So I'll say for I in range len self.lst -1, then -1, then -1. I'll explain what it is. So basically we'll start by so let's say the list here in our case, if we have 1, 2, 3, the list length is 3. So when we say len list -1, so 3 minus 1 is 2, because the last index is 2, okay? And this -1 here represents the limit. So let's say I starts with 2, it ends with 0, because -1 here is excluded. Then this -1 is the decrementation. So each time we decrement I by -1 or by 1. And of course, before trying it, we need to fix here. So self.lst index I, like this we will mention, or we will fetch the element using the index. So now let's run the Python file. As you can see, now it works correctly, 3, 2, and 1. Another method I want to show you here is to find the top element. And the top element is actually the element at the top. It's basically it. So here in our case, it is the number 3. So how can we return this top element? First, let's create the method. So def top, and it will accept self as parameter. And all we need to do here is actually use indexes. You'll see why. So we'll say return self.lst and which index is the top level element. As you can see here in this comment that I left it earlier, the number 3 is actually at the last index. So basically, if I say right here, and how do you actually mention the element at the last index, you can say -1. So this will fetch for me the element at the last index, which is 3. And as you can see, if I run my code, there is number 3, and this is the number on top. And this is how you return the top level element. So if I go ahead and say right here, after this, I'll say print and stack 1.top. Like this, I should get the number 3. And there it is. However, a common practice here is to actually first check if the stack is not empty. So I will say self.isEmpty equal to true. And if it is equal to true, I'll return, let's say, a random string like none or none, okay? Else, well, let's return the top level element, and that is it. If you want, you can do that, but it is of course recommended to do that if the stack is empty. Now it is better to actually allow the user to input the elements rather than hard coding them like that, okay? So what we will do here, let me delete these lines, and we'll create a simple function, not method, a function outside the class. I'll call it fillStack, and it will take an object of stack as parameter. And let me show you what it will do. So I will say fillStack and stack1. So it will take my stack1 as parameter. What I will do here is I will allow the user to input how many elements they want. So what I can do here is I could say while true. And you'll ask me, why am I developing or building a infinite loop? Well, stick with me for a moment and you'll see how we will be able to stop this loop. So I will ask the user to integer input, or to input for me an integer. So I'll say int input a number, okay? So the user will input for me a number. What I will do here is I will store this number inside my stack. So because the parameter object stack represents my stack1, I can say object stack dot push the element which is x. But this is now an infinite loop, it will never stop. How can we stop it? Well, we can add here inside the parentheses and tell the user to, let's say, input any letter to stop the program. To stop, okay? However, we know here that if the user inputs a letter, it will launch an error because a string cannot be converted to an integer. What we can do here is put this inside a try and except block. Like this, we'll be able to handle the error. Let me add here except. So if there was an error, it will be thrown inside the except block, and like this we will know that whatever the user typed, it is not a number. So basically, let's break out of the loop. Now let me go ahead and say stack1.display, so let us see the elements of our stack. So let me run my code, and as you can see, it's asking me to input a number, so 12, 14, 16, stop here, there it is. So the first element was 12, it is at the bottom, then 14, and then 16, which is the top level element. Now I'll give you a simple exercise. Based on what we did so far, create a function that takes as argument or parameter a stack and try to reverse it. So basically, reverse a stack. So pause this video, do it on yourself, and come back. Right after the fillStack function, I'll say def reverse stack, and we'll take the initial stack as argument or parameter. So look what I'm going to do. I will create a reverse stack object equal to stack. So this is a stack object, and what I will do here is I will use a while loop, and I'll say while initial stack dot is empty is equal to false. What I will do here is I'll say reversed stack dot push, okay? And what I will push inside or add inside the stack is the elements of the initial stack. So initial stack dot pop. And when you use the method pop here, it is actually taking off the element from the initial stack and putting it, because we are using the push method here, and putting it inside the reverse stack. So basically at each iteration, the initial stack is decreasing, and so we will arrive to a point where the initial stack will be empty, and that's how the while loop will terminate. So I'll say here print, let me print reversed stack, So reverse stack dot display, and actually I don't need to use the print statement here. Okay, now let me call the method, so print reverse stack or reverse stack and stack 1. So first we need to actually fill the stack. As you can see here, the function fill stack is allowing me to fill this stack. So I'll say 12, 13, 14, 15, and now let's stop here. As you can see, this is the reverse stack, 12, 13, 14, 15. Well, it was better if I actually print the before and after. So let us go ahead here and say, well, not print, stack 1 dot display. Like this, we will know the before and after, it will be better. So let's say here, let me go for 1, 2, 3, 4, 5, basic. Now let's stop here. As you can see, 5, 4, 3, 2, 1, and there it is. Starts from here, 1, 2, 3, 4, 5. And this is how you reverse a stack. And this is it about stack data structure for today. I hope you understood this concept, because in the next video we will talk about the sister of stack, which is called queue. So make sure to subscribe. Other than that, I invite you to click on one of these end screens that will appear right now. And I hope to see you in one of these videos.